measure MEAS የሚለው match status የሚለውም ማውጣት እንችላለን ለጊዜው።
Perfect. Okay, exactly what we want to look at. Okay, so in the measurement group, you can see some important variables here. We have your CO2 sample, your CO2 reference, your water sample, your water reference. So you can get a sense of what the conditions were in the chamber when you took measurements. It looks like ambient CO2 concentration must have been around 420, and that's what you said. And if we scroll over to the right, I'd like to see some other variables.
እዚሁ ሰንጠረዡን ወደ ቀኝ ከታች
ታች
Okay, go ahead and keep going. And keep going. Okay. Okay, so here we can see what the light level was outside the chamber. That was one of the things I was interested in. So Q ambient out, it looks like for the first observation was around 100, and for the second observation was around 50. So that can mean a number of things. One thing is if you had perhaps, tilted your external quantum sensor or somehow had it covered, or if maybe a leaf above was covering that sensor when the measurement was logged. For whatever reason, the light level outside that the sensor was measuring at the point when you logged was lower. And it looks like, you set the light around 150 for these measurements, which maybe the ambient conditions were changing. I don't know. Can you tell me a little bit more about this measurement and how you set up the system and give me a little bit more information?
Okay, by default, we are covering the light sensitive part. That is why we are count is 47.9. After we see, we immediately remove out that cover.
Okay, so you saw the light level changing is what you're saying?
Yeah.
Okay, yep. Okay, one thing we recommend if you're taking measurements on, let's say, a partly cloudy day or a day when the ambient light level is changing a lot, it is difficult to take survey measurements under those conditions. We definitely realize that. One of the things we do recommend, though, is that if your ambient light level is fluctuating from, in this example, from 50 to 100 over, a few minutes time, then we actually recommend choosing the lower light level to set your light level in your chamber. And the reason for that is leaves adjust very quickly to a decrease in light, but they take a really long time to adjust to an increase in light. So if you choose the lower light level that you're measuring, then, as soon as you put that leaf in the chamber, it maybe will only take a minute or two for the leaf to adjust to a decrease in light. But if you had decided, I'm going to choose the highest light level that we're measuring over this time period, and you took a leaf that was, had just seen a much lower light level and put it in the chamber at that higher light level, it could take 20 minutes or so for the leaf to adjust to an increase in light. And your whole goal with survey measurements is that you're trying to get a snapshot of a large population of leaves. And so you really want to leaf taking a measurement in a minute or less. If the conditions are set where the leaf has to adjust, then that is really going to limit the number of photosynthesis measurements you can take. And that will really limit your ability to, to use that experimental data. You won't be able to get much data. Not only that, your data will be really variable. So it'll be hard to tease out the differences that you're looking for. If your differences are a cultivar or a treatment or something like that. If you're not setting your chamber appropriately where your leaf has to adjust to your chamber conditions, then you're not really going to get a good assessment of the current state of the leaves. So that's one of the key things is figuring out your light level and making sure that you have it set appropriately in the chamber. One thing I'd like to see is I'd like to see the observation time. So if we look, I cannot remember what group that's in. Do you remember, Elizabeth? Time?
It's in a couple of different ones with gas. That's actually that one too.
If you scroll to the left on this, let's see whether we have a timestamp. We want to see how far apart these two measurements were. In the measured group, if you just scroll in that.
ሰንጠረዡ ውስጥ ማለት ነው ከታች
ሰማያዊን ስክሮል አድርጋት እሷን እሱ ጋር
all the way.
Okay, that's really hard to read.
Oh, this one has measured time from the Unix epoch. GasX has one, I think, that is not the Unix epoch.
Okay, so go up and select the GasX group.
I think so.
I think there's 2 minutes, 200 seconds roughly, 200 something seconds, so about 3 minutes.
Okay.
ገብረ ኪዳን gas X የሚለውን እስቲ ቼክ አድርገው። It's the same.
There's one called observation time, I think. Anyway, okay. 3 minutes is a good time between measurements. It looks like they're fairly consistent. So that's good. It is just a low light level. And so, your photosynthesis rates, your conductance, transpiration, all of those are going to be low. I do in your CI column, I'm assuming this is a C3 plant, but that is a very typical CI value and they look reasonable. So those are things that I would look for. If you had sent me this data file and said, is this reasonable data? Looking at all of this, I would say, yes, it is. And again, it's based on your light level, what type of plant you're measuring, what the ambient conditions were like, and then looking at these calculated parameters. Do they make sense for the type of leaf that you're measuring? And these look really good. I'd like to look at another data file. If you collected more data together.
I think they had 3 files. ሶስት ነገር አይቻለሁ ልበል። I think 3.2 ሚል አለ። GR1 ሚለው ምንድን ነው? Yeah, 3.2 እንየው እስቲ። Is it the same tree? ሌላ ዛፍ ነው? Okay, it's a different tree. There we go.
Okay, yep, let's look at the data. Okay, let's look at gas exchange group. And also let's look at your measure group.
Where is it?
Where did I go to? ጋስ ኤክስቼንጁን ተው። አሪፍ አሁን ጥሩ። ሁለቱም አንድ ላይ።
Okay, so you have one leaf that had much higher photosynthesis rates. Do you see that? Your first two observations were very similar to the last data file we looked at, where your third observation, you had a much higher photosynthesis rate. You also had a much higher CI value. That does not look reasonable at all. And your transpiration rate was negative for your third observation. So that does not look reasonable. If you scroll over to the right, okay, let's see. Oh, too far, too fast. Go to the left a little bit.
ወደ ግራ ሄድክ በጣም። አይ ቲንክ ስቶማታል ኮንዳክተንስ ጂኤስደብሊዩ የሚለው አካባቢ ተመለስ ትንሽ። አሁንም ወደ ግራ
To the left.
ቀጥል።
GSW.
አንድ እንደገና።
Okay, there we go. Okay, so there we see your first two, again, had low stomatal conductance, but reasonable, where your last one was not a reasonable stomatal conductance. So if we keep scrolling to the right, I'd like to look at your CO2 reference and sample and your water reference and sample.
CO2R, CO2S የሚሉ ስታገኝ ቀጥል። ያ
What was it? On all of the observations? Okay. So let's go back to the left. Sorry. Elizabeth pointed out that I didn't notice that column, the relative humidity column, RH. Oh.
So if you look, please, there we go. So you see that RH chamber is 28%, 25%, and I also noticed that your VPD leaf was in the 3s. So one of the reasons that you probably have low stomatal conductance, other than the low light level you may have been working with, is that the relative humidity was a little too low. Remember we talked about how we want to have the boundary layer, we want to target boundary layer stomatal conductance. And boundary layer stomatal conductance is going to be quite a bit higher than 25 to 30% RH. And the VPD is going to be quite a bit lower than 2.5 to 3-ish. So one of the things that you could do to improve your measurements in the future is you could set your RH a little bit higher or set your VPD a little bit lower. So we could set our VPD to 1.5, or we could set our RH to somewhere between 50 and 70%. And I suspect you would get slightly better stomatal conductance values, even in a low light level, because at this point, the low light level and the low water availability are combining to make the leaf say, no, I won't do photosynthesis. I won't do gas exchange. And so it means that it's harder to make measurements. So that's something you could